Hello everyone, welcome back to the VLSI Toolbox channel. Today we are diving into part 4 of our analog circuit sizing series, where I will be demonstrating the various steps in design verification process, followed by post-layout simulation. So before going to the tool or other things, let us know what are the available verification tools in the market. There are three main company, that is Cadence, Mentor, now it is a Siemens business, and Synopsys. From Cadence, Assura tool, from Mentor, Caliber tool, and from Synopsys, IC Validator tool. In this video, I will be showing you through Assura tool, that is Cadence itself. So these are the files required for running the backend process or verification process. .drc file, .rule file, .rsf file are required for DRC check. So only in this video I will be showing you through rule file, that is Assura required only .rul file and rsf file. RSF file is optional, so .rul file is enough for the DRC check. And for LVS check, layout versus schematic check, extract.rule, compare.rule files are required. And for PEX, RCX setup.template file is required, and LVS rule sets are required. And one more file for Assura TechLib. This file have to be configured in the working directory, which will point the path of the rule file of a particular PDK. So let's move on to the demo and see how it works. So this is the layout as I have shown in my previous video. I am starting from there itself. Now I will be doing and showing you the rest part, that is verification part. So before verification we have to create pins and create labels. So for creating pins we have to go to create pin Pout. Now select ME3 because this is the ME3 layer. Output pin, height, draw a rectangle. Then press L for label Pout. So I have marked the pin as Pout. Now remaining, that is CC. Again go to create pin CC. It is case sensitive, so you have to give as it is. L CC. Next VDD. For VDD you have to select ME1, create pin VDD, L VDD, so VDD I have marked. Ground, remaining ground, VSS. VSS. Next, B in plus and B in minus. For that, this is B in minus is of metal 2. So select ME2, create pin B in minus me2 L B in minus again bean pass is for using M3, so select M3 first, create pin plus plus next one pin is remaining IPS, so again go to create pin LVS. So I think all pins are connected. Save. Now let's start checking. First of all, we will do DRC. We will use a tool called Assura from Cadence itself, and other tools are also available that I have shown in the slide. So go to Assura, run DRC. So you have to give this thing, first set this thing, and this is the rule file. It will be taken automatically if everything is configured correctly. For Assura configuration, you need to have Assura underscore tag.lib file in your working folder, and it should be configured. It should be defined all this path of your rule files. So press OK, OK, yes. So there is some problem. Metal 1 to metal 1 spacing should be 0.24. So let's check it by clicking this arrow. So there is a gap. Just align this. Let's check the width. Okay, it's fine. So next is a metal 2 to metal 2 spacing. Metal 3 width 0.28. Extend this. Let's check again. Assura, run DRC. So some reduction is there in the DRC. One more metal 3 width. So you can individually check the layer. Now save all view. Using no view all view switch, you can select the individual layer for visualization, better visualization. So let's check again the DRC whether it is clear or not now. One error is remaining. Let's draw this layer, extra layer, to manage this gap. Now let's check again. So no DRC for error found. So DRC is clean now. Now we will go for layout versus schematic check. Go to Assura, run LVS. This setting will be done automatically. This is again configured in Assura TechLib file in the working folder. So press OK. So LVS is now clear. Now we will move forward to parasitic extraction for our resistance and capacitance extraction from layout. So for that we require another software, Quantas, where we have to set up the Assura along with Quantas. Quantas will run the parasitic extractions. For that, go to setup, check what type of extraction you need to do. We have selected RC. Next, your reference node BSS, as you have used BSS as reference node, and filtering options, you have to check this UMC 18 CMOS LVS rule set. This is also configured using Assura_tech.lib file. So you have to check it. In a net listing, you have to set like this. Run details, you have to check. Then go press OK. After that, go to Quantas again. Run Assura Quantas. So it will come like that. Rule set is LVS, EMC 18 CMOS, extraction is RC as we have set it earlier. Filtering, you can filter the power nuts. Net listing same. Setup. Output type is extracted view. You have to select. Press OK. So parasitic extraction is completed successfully. You can see the message. Close it. Go to library manager and check a view called AB extracted. Open this. You will find the extracted view where you can see, if you press Shift F, you will see the resistance here, resistance, capacitance, everything extracted from the layout. So now we will simulate using this view as a post layout simulation. Close the layout, and from the schematic itself we have to create one symbol for the design. So go to create cell view. From cell view, press OK. Give your pins orientation. BTD in general it should be in the top, IBAS top, BSS in the bottom pin, and CC So in this way I can manage. That's okay. So it will create one symbol of this. Okay. So using this symbol we will simulate. Now let's create one test bench. TV. IBase 30 macro. Press Q. Select the instance. Press Q. Okay, give the values 30 macro. Seven pico. CC 2.1. CC 2.1. And 500 milli DC voltage for biasing the input pairs, and we require AC magnitude of 100 macro. Check and save. Now launch IDL. We have to check whether it is coming using schematic or not first. So setup model libraries. Okay, it is correct. Analysis tools, DC, AC, run it. Results: direct plot, gain and phase, V out by V in. So almost 71.41 dB, that is normal schematic value. Now we will check for layout. So for doing post layout simulation, there is two methods. So first of all I will show you the shortcut one. Go to environment, give the view name. Our view name is AB extracted. That is the view extracted from PEX, that is parasitic extractions. After getting parasitic extraction, the view we have obtained as AB extracted, which I have written in the first. Press OK. Now it will simulate using layout. Run it. So it's running. Go to results, direct plot as a gain in phase, P out by B in. So again it is same 71.39. So almost no variation in the gain plot. If you want to check, you can click on that. You will see that this is the layout. Under the symbol it is layout. Previously it was schematic, but now it is layout. So this is the post layout simulation of for gain. You can also check for other analysis, that is that I have shown in the front end part. You can do all the analysis that I have shown in the front end part. So this is one type of post layout simulation. Let us now check the other way of doing post layout simulation using a view called config. So for that you have to copy this same setup and give the same signal to the input, and you have to rename this. One is for B out S, another is B out L. So this is the output from layout, this is the output from schematic. Second save. Now write a new view called config here. So config, type config, open with hierarchy editor. Okay, then view schematic, use template. Okay, then this view will come. Go to tree view. Here the first one, that is in the schematic, first one is for, select this first I0 and give it to schematic, and select the second I17 and give it to AB extracted. Save it, close it. Now go to the config view. Yes, okay. If you double click it, then you will find this is schematic, and if you double click this one, you will find it's a layout. So I have given two separate views in these two setup. Second step. Now go to launch ADL and run from this analysis. Choose S analysis 1 Hz to 100 megahertz, suppose logarithmic 100 points y. Now run it. So results, direct plot, gain and phase, P out by B in. Again, if you want to check both the, then change the plotting mode to append. Go to results again, direct plot, gain and phase, P out L by B in. So remove the phase for better visualization. Now you will see almost the two waveform will be same. So I can simultaneously compare both the result using this method. One is 71. If you want to check using vertical marker, you can check the slight variation. One is 71.46. that is first one is your schematic, and this one is a layout. One is 71.46, one is 71.55. 0.51. So this is the difference between the two, layout and schematic. So in this way you can check all the analysis that I have told in my previous video and shown in my previous video, and you can check the post layout simulation for power, noise, everything. So that's all for post layout simulation. So hope you have gained valuable insights into layout design verification and post layout simulation from this video. If you found this helpful, don't forget to share and subscribe to my channel for more informative content. Thank you all for tuning in and watching.